So today's lesson is going to be page number 4 in your notes. We're going to skip page number 3 and come back to it after we do page number 4 later on this week. So our first lesson is called Segment Addition Postulate and Midpoints. So to start, we're going to learn a new word. It's Segment Addition Postulate. The word postulate, P-O-S-T, my pen has died, hold on. P-O-S-T-U-L-A-T-E. A postulate is kind of like a theorem, but a postulate is just an accepted math fact. So a theorem has to be proven, like the Pythagorean theorem is a proven theorem, whereas a postulate is just something that's true. So piecing apart our words like we did before, segment meaning, a beginning and an end of a line, addition meaning added, and postulate meaning accepted truth. So what we're doing is we're basically just adding this segment plus this segment together to get the full segment of AX. So segment addition postulate, the abbreviation for it is S-A-P, SAP. So the way that we get that is just from the first letters of each piece. So segment addition postulate, SAP. So when we start to do proofs later on in a couple chapters from now, we'll be using that abbreviation a lot. So we want to make sure that we know SAP stands for segment addition postulate. All this means is that I'm going to add small segments together. So the length of segment AR, if we add segment AR plus the other segment, segment RX, so R all the way to X, when we add both of those segments together, the outcome is the full segment of AX. So this large segment of A all the way to X. So whenever we're working with segments, you can add smaller pieces together. So this segment AR, this little green piece, plus RX, which is the orange piece. If you add those two measurements together, you get the full measurement of AX. So whenever we're doing segment addition postulate, all that means is that we're going to add small segments together to equal the large segment as a whole. And you could add more than 2 together. In this case, there's only 2, but you could add 7 segments together, and that would still give you a full piece. So an example, if segment AR is 5 units, segment RX is 10 units, if I add 5 plus 10, that gives me the full segment of AX. 5 plus 10 is 15. So down here, 5 plus 10 equals 15. So segment addition postulate is just adding small segments together to equal the length of the full side. So we're going to do one problem together. Okay, down here it says if C is between B and D with a BC equaling 8x plus 13, BD equaling 10x plus 20, and CD equaling 12x minus 73, then solve for x and the length of CD. So the first thing that you want to make sure that you do is you want to make sure to draw the picture. So step number 1 is always to draw a picture. Now, if a picture is not available to you, you want to sketch it out. So this is where all our vocabulary really comes into play. If you don't know the vocabulary, you can't really draw the picture. So it says C is between B and D. Point B and point D represent the endpoints of the segment. It's where the endpoint, the segment starts and where the segment stops. So B and D are kind of the bumpers for our segment. Then it says that C is between it. Now, when it comes to the word between does not mean middle. If it means middle, it will say the word middle or in the middle or midpoint. It will give you one of those words. If it says the word between, that just means it could be here, 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 here. It could be anywhere in between B and D, just not the middle. So I'm going to go ahead and put point C right here. There is no incorrect way to put point C other than the middle or outside of the boundaries. So whenever you're reading these, the boundaries where it says between B and D represent the boundaries of the segment. You can't go past it. The second thing we want to do is label the picture. So step 1 is to draw the picture. Step 2 is to label the picture. So draw the picture first. Step 2 is to label the picture. You want to make sure that you label it because it's a lot easier to do these problems when you have visual representation. If it's not labeled, it is trickier to do. And you also just want to make sure that your picture has all the information that you need to make problem solving easier. Think of this picture as a blueprint to the problem. If you miss some of the steps, you're going to have a hard time finishing it because you don't have all the pieces. So we're going to start by labeling. Segment BC is 8x plus 13. What that means is between B and C, this segment right here, that segment value is 8x plus 13. So we're going to write that right here, 8x plus 13. Now notice on this other picture, we put 5. Now we have a little equation, which means we're going to actually have to solve that problem whenever we do these. So don't freak out that there's not like an actual number. This value will eventually become a number. So this one was 5. This is now 8x plus 13. It's the same thing. Next, it says BD is 10x plus 20. So the length of BD, this one is tricky. B starts here and goes all the way to the end. That is the full segment. So notice how it's listed second. These pictures don't always go in order. So whenever you're labeling, you want to make sure that you follow the letters to kind of guide you. So this length is 10x plus 20. Always make sure to write it underneath the segment so you know that it represents the whole thing. Notice how we did that right here where we said AX was 15. Same idea. BD is 10x plus 20. And then our last piece, it says CD is equal to 12x minus 73. So to find those pieces, I'm going to go in between C and D. So in between C and D, and we're going to put its measurement, 12x minus 73. Just like over here, it said 10. Now it's 12x minus 73. So step 1, draw the picture. Step 2, label the picture. Step number 3 is to write the equation. So step 3 is to write the equation. Now, when you write the equation, it's really important to set it up with letters first, then numbers. So when we write the equation, it's going to look something like this. We're going to put letters first. This is called a general equation because it works for any equation. This is called a specific equation because it has specific values. So we're going to write the equation using these letters. We're going to first do the small segments. So BC plus CD. And if we add those two tiny segments together, we get the full segment of BD. Just like over here, we got the full segment of AX. Once we write our equation, then we're going to substitute. So that's where we replace the letters with actual numbers, whereas this one right here, AR is 5. We replaced AR with 5. So over here, BC is 8x plus 13. So underneath BC, we're going to put 8x plus 13. All we're doing is replacing this value of BC with an actual number. Then we're going to add the length of CD. CD's measurement is 12x minus 73. So we're going to replace CD with 12x minus 73. And since we're only adding two segments together, we can stop after this part and put an equal sign. After the equal sign, that's going to represent the full length of the segment. The full length of the segment is BD, which is 10x plus 20. So where we see BD, we're going to write 10x plus 20. So always remember when you're doing segment addition, the small values go on the left. These are the two smaller pieces. The whole segment goes over here. So if we need to add that over here, these two pieces, those are the small segments, the little chunks. Over here, this is the whole segment, meaning the whole entire length. To continue solving, what we're going to do is combine like terms. So back in Algebra 1, we practiced combining like terms. It's been a little while since we've done some math, so we're going to practice. So after we write the equation, and substitute, because that was step 3. Step number 4 is to solve for the variable. And in this case, our variable is x. There are lots of ways to solve algebra problems. What that means is you can isolate the variable on the left or you can isolate it on the right. It's completely up to you. It does not matter. There's a ton of different ways to solve algebra. So if I'm solving it a way that you're not comfortable with, that's okay. You can pause the video and just kind of solve it how you want to, and then check your answer at the end to kind of test those algebra skills. If your algebra skills are a little weaker, just follow along with me and we'll kind of talk through how to do each of these problems. So working through this step, the first thing you have to do is look at the left side of the equation. So I'm going to look at the left part from the equal sign. I'm going to look for like terms, and in this case, I have an 8x and a 12x. So what I need to do is I need to get those like terms together. Okay, so I'm going to do 8x plus 12x. 8 plus 12 is 20, and I put x on the end. Then I'm going to focus on the numbers. So I have a positive 13 and a negative 73. So I'm just going to add those two numbers together. So 13 plus negative 73 is negative 60. So I'm not going to put plus negative 60. I'm just going to put minus 60. That's the exact same thing. You can also do it this way, 13 minus 73. It is completely up to you and how comfortable you are with algebra. I'm never going to tell you to do it one certain way. I would do it this way if you're struggling, and this way if you kind of understand that the plus becomes minus. Then we have nothing to combine over here, so I'm just going to bring that whole side down. Now we got to think about what to solve and what to move. Personally, I like to keep the value of x positive, and if I move that 20 to the other side, it will be a negative. I don't want that. So I'm going to subtract 10x, and the reason now we're doing the opposite sign is because we're moving it to the opposite side of the equation. So 20 minus 10 is 10. 10x, we didn't touch minus 60, so we bring it down. This cancels. And then we didn't touch the positive 20, so we just bring the 20 down. We're going to continue to solve. I want to move the 60 to the other side, so I add it. And I get 10x. The 60 cancels. 20 plus 60 is 80. Now our goal is to still isolate the variable of x. So to get x by itself, we're going to divide both sides by 10. So our value of x is 8. Now, in our question says to solve for the value of x and the length of CD. Well, we have our x value. Next, we have to solve for the missing length. So that's step 5. Solve for a missing length. Now, not every problem is going to ask you to do that. However, this problem says to solve for the length of CD. The length of CD is not 12x minus 73. That's just its equation. We need a measurable distance. Like we talked before about the ruler, we need an actual number on a ruler. 12x minus 73 is not on a ruler. So to solve for that value of CD, we're going to take CD's equation. Okay, so we're solving for CD. Its equation is 12x minus 73. So CD is equal to 12x minus 73. That's not a final answer. We have to solve for the value of x. Notice here how x's value is 8. So we're going to take it and plug it in. And this becomes 12 times 8 minus 73. So 12 times 8 minus 73 is equal to 23. So the length of CD is 23. Always make sure to check. If we're solving for an actual measurement, we want to make sure that we're doing that. X is part of the problem, but the way geometry takes it up a notch compared to Algebra 1 is that it asks you to solve for measurements, not just for the variable of X. So in this case, you want to make sure that you're satisfying this equation. So it asks you clearly to solve for X, and we did. The X value is 8. Then it asks you to solve for CD, and we did. That value is 23. What I like to do is kind of write that underneath in my problem so I know I'm solving for everything I need to. That's the trickiest part in geometry, is missing that final step. All right, in the next part, we're going to do midpoint and segment bisector. All right. So midpoint versus segment bisector, we're going to talk through these together. What day was it? On Thursday, we talked about the definition of midpoint and the definition of bisector. Remember, the definition of midpoint is that it's the point in the middle. Midpoint is the point in the middle of a segment. Point in the middle. Okay, point in the middle. So in our picture, we're going to have the letter M represent the middle. And that's going to be our midpoint. Now, we set up midpoint problems similar to segment addition problems. It's just different keywords. So to show that this is the midpoint, remember we use those little rulers. Because segments are linear, we use rulers to measure them. So to show that they're congruent, we use those little bars to kind of symbolize little mini rulers. Our segment statement, segment AM, is congruent to segment MD. What that means is these two measurements are the same. So let's say AM is 5. That would mean that MD is also 5. The value of 5 equals 5. Now, a segment bisector, remember we talked about the game Fruit Ninja. You throw this little fruit in the air and you slice it in half. That is exactly what a segment bisector does. A segment bisector is an actual line that cuts a segment in half. So line that cuts a segment in half. It's basically just like a midpoint. The midpoint is the after effect where it's already been cut. The segment bisector, we'll name that L, is a line that cuts that segment in half. So point R in this picture is actually still a midpoint. It's an actual midpoint. However, the line itself, line L, is referred to as the segment bisector. So the line L is the segment bisector. Point R is a midpoint. So what that means is the length of LR and RQ, they are the same because it cuts it through the middle. So segment LR is congruent to segment RQ. Same thing. If this is 5, so is this one. 5 equals 5. Now, I'm just making up that random number. It doesn't mean anything. You could use 187 equals 187. It's the same thing. I'm just choosing a small number to have this be a little bit easier to understand. All right, so we're going to do some midpoint questions. Now, the midpoint questions are just like segment addition questions, only they're going to be set up a little bit different depending on the information that you have. For a midpoint, notice how we don't have information about AD. That means we set the two pieces equal. If we did have information about AD, we want to treat it like the top, like the segment addition problem. Okay, so we're going to do 3 practice problems to talk through midpoint and segment bisector. So the first example down here, labeled number 2, because it's the second one we've done. It says, if P is the midpoint of AB, with AP equaling 6x plus 5 and PB equaling 3x plus 26, solve for the length of AB. So remember our first step. Step number 1 is to draw the picture. It's telling you that the segment name is AB. So what that means is AB, those are our little boundary points. A and B. Those are the barriers of our segment. They kind of keep our segment in check. It's the beginning and the end. Now it tells you that point P is the midpoint. Now notice how it doesn't say the word between. It says midpoint. So midpoint actually means middle. The word midpoint means middle point. So in the middle is about here. Try your best to draw it. Sorry, my dog is going crazy. P is in the middle. So what that means is we're going to draw point P as close as we can to the middle of the segment. Oh, that highlighter doesn't look good. All right. Our next step is to go ahead and label the midpoint. So midpoint means middle. So that means that this length and this length are the same. Notice in that first problem up above where it says between, the word between does not mean middle. So we don't put it in the middle. But the word midpoint does mean middle. So we want to make sure that we put it in the middle of the segment. Next, we want to label. So draw the pictures first. Step 2 is to label the picture. Notice how it says AP equals 6x plus 5. What that means is between the length of A and P, we're going to put 6x plus 5. Okay. Next, PB is 3x plus 26. So between P and B, we have 3x plus 26. Find the length of AB. Now, in this question, notice how it doesn't ask you to solve for the value of x, but in order to get the length of PB or AB, you still actually need to know the value of x because we can't really add those together because we don't know what they equal. So in a problem like this, notice how we don't have any information about AB. Okay, it doesn't look like the segment addition problem. It kind of looks like this problem where we only have the two little pieces. So what that means is we want to set those pieces equal to each other. So the first thing we're going to do is set them congruent. Segment AP is congruent to segment PB. Now, before we put any values in there, in order to use an equation, we need an equal sign. So now we're going to change it to AP equals PB. If things are congruent, that means they're also equal. This is called the definition of congruency. When you go from here to here, this is called the definition of congruency. And I'll use the symbol for congruent. When we get to proofwriting, we'll be using that symbol a lot, as well as this little trick, definition of congruency. So we're going to start now so we have some practice. So the value of AP is A to P, and it's 6x plus 5. So where I see AP, I'm going to put 6x plus 5. That's going to equal the length of PB, and the length of PB is 3x plus 26. Now, some of you may be asking yourself, if these are equal, why don't these equations match? The reason the equations don't match is because if we set two things that were exactly the same equal, if we tried to solve for the variable, it would disappear. But when we get the value for x, when we plug our x value in, then we'll have the same number answers. So the equations are different for a reason. It's because we have to solve for the value of x. But by setting them equal to each other, that lets us know that they are in fact the same, but in order to solve the problem, they need to look different until the end. So what we're going to do is solve for x. So I'm going to move the 3x by subtracting it. And if you're really confident at algebra and you can do more than one step at one time, that's totally okay. I just want to make sure that I show every single step because I don't want anybody to feel left behind by me skipping a step. But if you're good to go, you can definitely skip steps and solve it however you want. I just don't do that in notes because I just want you all to have a chance to kind of follow everything. Next, I'm going to move the 5 by subtraction. So minus 5x. So 3x, these cancel. 26 minus 5 is 21. To get x by itself again, we're going to divide by 3 and we get an x value of 7. Okay, so x is 7. Now we need to know the length of AB. However, the length of AB isn't shown here. We have nothing. All we have are these two tiny segments. So what we want to actually do, if we're needing to solve for the length of the whole thing, AB, but we only know AP and PB, what we want to do is go ahead and solve for each of those pieces. We know that these are equal. So I know AP's length is 6x plus 5. Well, we just unlocked some information here. We know that x is 7. So 6 times 7 plus 5 is 47. Now, you can do one of two things. We know that P is in the middle, so that means if this length is 47, this one should be 47. Or you can check your math to make sure you did your math right by plugging it into the equation separately. So I'm going to take the 7, plug it in for x. 3 times 7 is 21, plus 26 is 47. Notice how they match independently, which means we did that correctly. Now, if I want the full length of AB, I'm just going to add those two measurements together. I'm going to add this part plus this part. 47 plus 47 is 94, which is the length of AB. So remember, as you're solving these problems, you want to make sure to keep track of your answers, and you want to make sure that you're answering the question that it's asking you. So all we've done in this kind of problem is we know point P is in the middle. We solved for each piece independently. This length here, AP, gave us a length of 47. PB also gave us a length of 47. I made them the same color because they are the same value. So notice how this problem is slightly different from segment addition. In this problem, we're setting the values equal to each other because they are equal. Whereas up top, we added the two segments together to equal the whole thing. All right, let's try the middle. Middle is another midpoint question. It says if J is the midpoint of LO, with LJ equaling 3x plus 18 and LO equaling 9x minus 15, solve for the length of JO. Step 1, draw our picture. So to help us draw the boundaries, it says that J is the midpoint of LO. That means when we draw our segment, L and O are those ending points. So L is here, O is here. So those are kind of like our little boundaries. Okay. All right, next. It says that J is the midpoint of LO. Just like over here, midpoint means middle. So now we're going to name the midpoint J. Let's see. I think this looks about the middle. Okay, and your picture is not going to be perfect. It's okay. It doesn't matter. Just try your best to put it in the center. Now, to show that it's in the middle, we need to make sure to put the bars. That's very, very important. It goes with the definition of midpoint. If you just put a point in the middle, I don't know it's really in the middle until you put these little bars. The bars mean congruent, so we want to make sure to label our picture accordingly. All right, next, it says that LJ is 3x plus 18. So from L to J, LJ, L to J, this segment is 3x plus 18. So right above it is 3x plus 18. So step 1 is to draw the picture. Step 2 is to label the picture. All right, now, if we aren't reading our question, we're probably going to want to try to do that problem exactly like this one. But notice how it says LO equals 9x minus 15. The value of LO is represented by the full measurement of the segment. So L all the way to O. That length is 9x minus 15. The whole thing. That's different from this question because in this question, it never mentioned anything about AB until the very end. So in this problem, it's a little bit different. When we do problems like this, it's very, very easy to get caught up in some of these equations. And I'm going to grab a separate sheet of paper real quick. So right here, this is something that a lot of us are going to want to do, and I'm purposely going to erase this, so don't write it down, just watch. A lot of you are going to want to do this. 3x plus 18 equals 9x minus 15. Now, a lot of us are going to want to do that. And the reason we want to do that is because we are scared to put information on a picture because we don't want to be wrong. And we're like, well, I don't know if I can really put information on a problem. Like, we're missing this part, but all I have are these two things. And all I've learned is that they're equal. So I'm going to put them equal. That process is definitely not right. So you want to make sure as you're reading the questions that you're actually understanding what the question is saying. LJ, this measurement is only half of this segment. 9x minus 15 is the length of the whole segment. A half of the segment isn't equal to the whole thing. If I go to Subway and I get a sandwich, I want the full length of the sandwich. It's not the same as just eating half of it. The half of the sandwich doesn't equal all of the sandwich. So what you're saying here is that half equals all, and that's not true. However, what is true is that these two things are equal. So if this length is 3x plus 18, so is this one. Now, you're probably asking yourself, well, these are now the same, and I thought they weren't going to be the same, because over here they weren't. And the reason they weren't the same on this problem is because we were setting them equal. The reason that they're the same on this problem is because we know the whole entire segment. When you know the whole segment, that unlocks segment addition postulate. So the way that we want to do this is we want to add our two tiny segments together. LJ plus JQ equals the full segment of LO. Okay. As we substitute, we already know that LJ's measurement is 3x plus 18. Okay, we already know that, 3x plus 18. We also know that JQ is 3x plus 18 because they're the same. Then we have LO. LO is represented by the full segment, and it's 9x minus 15, which is here. So the trickiest thing to get past when you're doing problems like this is knowing when it's okay to put information that's not actually on the problem. You can't make these the same because you're setting them equal. Notice how we don't know anything about AB. AB doesn't have an equation. Whereas over here, we know information about the whole thing, which means we want to double the half piece. Now, if you don't want to write it this way, you could also write it this way. 2 times 3x plus 18. This means, hey, I want you to double that measurement to give me the whole thing. If you were going to do it this way, you'd want to distribute. Since I'm not doing it that way, I'm just going to write it this way. But this is completely okay to do. It gives you the exact same answer. So from here, we're going to combine those like terms just like before. We have a 3x plus a 3x for a total of 6x. And then we also have some 18s over here. 18 plus 18 is 36, so plus 36. On that right-hand side of 9x minus 15, we don't do anything. There's nothing to combine. So just kind of bring it all down. Now we're going to solve for our variable. And our first thing, I'm going to move the 6x so the 9x is positive. So to do that, I'm going to subtract the 6 from 9. And again, if you don't want to do it that way, you don't have to. It just is a preference of how you want to solve algebra. So 9x minus 6x is 3x. Bring down the negative 15. Our x's are now together. Now we need to get the numbers. So I'm going to add 15 to both sides. 36 plus 15 is 51. And that equals 3x. Then I'm going to divide by the number in front of x, which is 3. So 51 divided by 3 is 17. So our value of x is 17. Then we have to ask ourselves, did we actually answer the question? And the answer is no, we did not. The question wants the value of JO, not the value of X. You have to go through X to get to JO, just like over here. You had to get to x to get to the length of AB. So the value for JO is 3x plus 18. So JO is equal to 3x plus 18. We have our value for x, so we're going to plug it in. 3 times 17 plus 18 is 69. So the length of JO is 69. And that's it. Now we've actually solved our problem. The value is 69 units. Notice the difference between these two problems. Both of these problems are midpoint problems, but both of them are solved differently. If it's a midpoint problem without any information of the whole thing, you set them equal. If it's a midpoint problem and you know the whole segment length, you double the small piece, write it twice, and then it equals the big. So this is midpoint by setting them equal. This is using midpoint by using segment addition. It's okay to use both. They're not exclusive from each other. You can use them together, and you have to use them together, which is why we kind of learn them all at the same time. Our last problem is number 4. It's a segment bisector question. Now, remember, segment bisectors are just like midpoints. They go through points in the middle, but segment bisectors just have that extra line. You don't really do anything with the line. It's just there. It's still just a segment problem. It just looks a little bit different. So let's go ahead and draw that picture for number 4. Okay, there we go. So you can kind of see my notes over in the corner. So it says that line L bisects AC at B. What that means is AC, those are those little endpoints that we talked about, A and C. Okay. So over here, how we talked about L and O, this point is A, the other endpoint is C. So AC kind of represents this beginning of the segment and the end of the segment. Okay, those are like the boundaries. It tells you that line L bisects, and the word bisect means to cut in half, just like midpoint means middle. Bisect means to slice in half. It goes through the middle at B. Now, what that means is this point B is the midpoint. Point B is the midpoint. Okay, so I'm going to kind of abbreviate midpoint here. Mid-PT. Okay, which means point B is in the middle. That is our midpoint. Oh, that marker does not like that pen. That is point B. That is just a horrible, horrible color. I did not let that dry. All right, now we're going to draw line L. Line L goes through AC. And it doesn't have to be like super big and huge. I'm just going to draw a little segment. Here is, or line, I'm sorry. Here is L. L represents our bisector. So this kind of goes here to here. That's line L. Okay. All right, we've drawn our picture. Step 2 is to label the picture. So our information states the length of AB is 19x minus 22. So A to B. Oh, and I forgot to put those little bars. Okay, it happens to the best of us. Just make sure you put those bars to show equal. So it says AB is 19x minus 22. So between A and B, I'm going to put 19x minus 22. Then it says BC is 8x plus 132. So between B and C, I put 8x plus 132. So step 1 is to draw the picture. Step 2 is to label the picture. Step 3 is to write the equation and substitute. So notice this problem, okay? Take a second and pause the video and just think about, would I set them equal to each other, or would I add them up to equal the full segment? So looking at this picture, do we set them equal, or do we add them together to equal the whole piece? The correct answer is to set them equal. And the reason we want to set them equal is because we don't know anything about the full segment. Even though we're trying to find it, we don't actually know any kind of equation that goes along with it. So we're going to have to do what we did in this first problem. Set them equal first, then solve, then add the two pieces together, and that will give us the full segment. All right, so segment AB is congruent to segment BC. Once we go from congruent, we change it over to equal. This is called the definition of congruency. And I'm going to abbreviate that. That's the definition of congruency. So we wrote our equation. Step 3 is to write the equation, which we did, and then we're going to substitute. So AB is 19x minus 22 equals BC is 8x plus 132. Now we're going to solve. So I'm going to move the 8x by subtracting. So 19x minus 8x is 11x. I'm going to bring down my negative 22, cross out here, and bring down my positive 132. Add 22 to the other side. Remember, the opposite of minus is to add. I'm going to bring down that 11x. 22's cancel. 132 plus 22 is 154. And then I'm going to divide by 11 to get x by itself. So our value for x is 14. Now, that's all fine and well, but again, that's not the goal of our question. The goal of our question is to solve for the length of AC. So we're going to do exactly what we did down here. I'm going to redraw that picture, or if you've got room, you are more than welcome to go back up to the top and kind of fill it in up there. Totally fine. So AB is 19x minus 22. I know that x is 14, so I'm going to plug it in. 19 times 14 minus 22 is 244. Now, you can plug it in again to see if you get the same answer or trust that your x value is right. Personally, I like to make sure that my x value is right. So I'm going to plug it in over here as well. So 8x plus 132. Take that x, plug it in. 8 times 14 plus 132 is also 244. So remember, point B is in the middle, which means this length and this length are actually the same. They are congruent to each other. So I'm going to go ahead and just add those up. 244 plus 244 is 488. So AC equals 488. And then I'm going to go back up to the top, put 488 here, so I know that I've answered the question. So some takeaways from this lesson: you want to make sure that you are labeling and drawing your picture. You also want to make sure that your algebra is right. So on the worksheet that you're about to get, you want to make sure you have plenty of space. If you want to work them out on separate sheets of paper, you go right ahead. So remember, segment addition, you're adding small segments to equal the full segment. Midpoint and segment bisector are basically the same thing, except a bisector actually cuts through the line, so it's got a little bit extra. And then when you're solving, it's important to know when to use segment addition and when to just set it equal. You set them equal if it's a midpoint question and you don't know the full length. If it gives you the full measurement inside of the problem, you use segment addition with the combination of midpoint here. You can also do that same idea if it said bisect, because this is also a midpoint. So drawing your picture and labeling what you have is going to make this a lot easier. Make sure that if you know the full segment, you use segment addition.